And of course, lastly, we will talk about vertical sweep efficiency. Okay, because we want to know our recovery factor. It is displacement efficiency multiplied by areal sweep efficiency and vertical sweep efficiency. Okay, vertical sweep efficiency is defined as the fraction of the vertical section. So it is about a vertical section of the pay zone that is swept by the injection fluid. All right. The vertical sweep efficiency depends basically on mobility ratio again. So mobility ratio is really, really important for our water flood, and also volume injected and vertical permeability variation. So again, heterogeneity, in this case, vertical heterogeneity is really important for our water flood performance. Okay. Of course, this kind of displacement that we desire from our water flood, piston-like displacement. Okay, that's the normal, the ideal story. But most of the time, that's not the way it turns. Okay, most reservoirs are stratified, vertically heterogeneous to some degree. So finally, you will get this kind of performance because of vertical heterogeneity. And of course, this interval or this level actually the highest permeability layer because your water move at the faster rate at this layer. Okay, our reservoirs are normally stratified or layered. There are a lot of high permeability streaks, fast zones, thief zones, fractures, and so on and so forth, and which will give us problems like again early water breakthrough, water recycling, which ultimately will give us poor sweep efficiency or poor vertical sweep efficiency. And what actually water recycling is? It is actually like this one, water recycling. So basically, you don't really push or displace your oil efficiently. Finally, you will just do water recycling. So you inject your water and then your water moves in the reservoir. It will be produced at your producer. And again, you will process your water and inject the water back into your injectors. And basically, you just recycle your water. And of course, there will be a lot of bypassed oils. Okay, there will be a lot of bypassed oil zones because of this inefficient operation. And that's we don't want, of course. So how we actually calculate or estimate our vertical sweep efficiency? There are a lot of approaches. We can do Stiles method, okay, provided that you know your permeability trend within your each well. And also you need to also do Dijkstra-Parson coefficient or Dijkstra-Parson analysis to obtain this V parameter, which will represent your heterogeneity. Okay, so if you have your log data, you calculate the Dijkstra-Parson coefficient for each well using this formula, and using that information, V and also mobility ratio, you can use this plot or you can also use this equation to finally calculate your vertical sweep efficiency. Because again, as a petroleum engineer or as a reservoir engineer, you need to actually estimate your recovery factor. All right, so this is easy. Provided that you know your mobility ratio, you just need to do analysis in laboratory to estimate the mobility ratio, and you need to also do reservoir characterization to obtain your V or Dijkstra-Parson coefficient to represent your heterogeneity, and you need to use this tool, either the plot or this equation. Okay, you can read it, the material in the textbook. It is in the literature. And if you have the V or Dijkstra-Parson coefficient from each well, you can create heterogeneity map. Okay, you can do kriging or you can do extrapolation to construct heterogeneity map, which will give you insight of how heterogeneous your reservoir is. I'm sorry, it's typo. So if you have V equals to 0, it means that you are completely homogeneous. Okay, your reservoir is completely homogeneous. But if you have V equals to 1 or approaching 1, it means that you have heterogeneous reservoir. And that's very important to give you the insight of how challenging your water flood will be. Okay, like this one, I have several wells. I analyze them, I calculate the Dijkstra-Parsons coefficient, and I create the map, and I obtain this one. So it means that my reservoir is really heterogeneous, which means if I implement pattern water flood, it will be very challenging and it might result in not really good water flood performance. Okay, so in this way, I know I need to actually implement irregular water flood rather than regular pattern water flood. Okay, so actually after you know displacement efficiency, aerial sweep efficiency, and vertical sweep efficiency, you can calculate your recovery factor provided by the water flood. All right.